AOPS Volume 1, the basics, number 95. Find the sum of all 4-digit natural numbers of the form of 4ab8, which are divisible by 2, 3, 4, 6, 8, and 9. So right off the bat, we're given that this answer has 4 cases because it tells us the sum of all 4-digit natural numbers. So there's 4 possible solutions out of this given scenario of the form 4ab8. And we're given these numbers that must be divisible by. And right off the bat, we see here that it must be divisible by 9 and 8. And I can ignore 2, 3, 4, and 6. And you might be wondering why I can do this. And the reason why for this is because 9 and 8 contain the factors necessary to compose 2, 3, 4, 6. 9 is equal to 3 times 3, 8 is equal to 2 times 2 times 2. You can take these numbers and form 2, 3, 4, and 6. Hence, if the number is divisible by 9 and 8, it is divisible by 2, 3, 4, and 6 as well. So whenever you approach divisibility questions, simplify it down to as few numbers as possible, because the more there are, the more likely you're going to get confused, and the more likely you're going to do it wrong. So with this out the way, we can find and understand the divisibility rule for 9. The divisibility rule for 9 is that the sum of its digits of a number must be divisible by 9. For example, 360 is divisible by 9 because 3 plus 6 plus 0 is divisible by 9. But what about the number 41? 41 is not divisible by 9 because 4 plus 1 is 5, and 5 is not divisible by 9. Hence, 360 is divisible by 9 and not 41. And what about the divisibility rule for 8? Well, there really isn't a trick for the divisibility rule of 8. The divisibility rule for 8 is that it must be a multiple of 8. That is all it is. So with this out the way, we can first deal with the special case of divisibility for 9. A plus b plus 4 plus 8 must be divisible by 9. Therefore, we can break this up to be equal to a plus b plus 12. So this sum must be divisible by 9, or in other words, be a multiple of 9. And when you're dealing with these types of summation and you have a restriction on some variables, it is always good to find the maximum sum of this quantity. So what is the maximum sum? Well, to do that, we must find the maximum values of a and b. And the maximum values of a and b can either be 9 and 9, because they're all single-digit numbers, and the highest single-digit number is 9. Therefore, a plus b plus 12 must be less than or equal to 30, because 9 plus 9 plus 12 is equal to 30. So the sum cannot exceed 30, and likewise, a plus b cannot exceed 18, because the maximum values of a and b are 9 respectively. And with this restriction, we can finally begin to do some guessing, which is organized guessing, not just random guessing. Of course, this is AOPS after all. And to do this, we know that a plus b plus 12 is a multiple of 9 because only multiples of 9 can be divisible by 9. So what are some multiples of 9? 9, 18, 27, 36, 45, and so on. But we know that a plus b plus 12, the summation of all 3 digits, must be less than 30. Therefore, we can ignore 36, 45, and onwards because a plus b plus 12 will never reach that area. And we can also be sure to eliminate 9 because 12 in itself is already greater than 9. So 9 immediately becomes extraneous. So we're limited down to a plus b plus 12 is either equal to 18 or 27. So let's write that down. A plus b plus 12 is equal to 18, or a plus b, that's a b, not an 8, plus 12 is equal to 27. Hence, if we scroll down, a plus b, if I scroll up again, having a little bit difficulty here, a plus b is equal to 6, a plus b is equal to 15, right here. So these are 2 restrictions of what a and b can sum to. But now we must find the form of 4ab8 because we haven't applied the divisibility rule for 8 yet for this number. So this is equal to 4,000 plus 100a plus 10b plus 8. That is what the expanded form of this number looks like. And we know that the sum of these numbers has to be divisible by 9, but we can be sure that is already a case, and we don't really need to worry about that anymore because we just found the possible conditions of the summation of a and b. So 9 is already taken care of for the divisibility rule for 9 in this number. We just need to care about the divisibility rule for 8. We know that 4,000 plus 8 is a number that's divisible by 8, so we can be sure to not care about that. And something about the divisibility rule for 8, the divisibility for 8, and for any other number is that the sum of 2 numbers which are divisible by 8 will give a number that is divisible by 8 as well. So 100a plus 10b must be divisible by 8, because if this is divisible by 8, added to 4008 must be divisible by 8. We can factor out a 10 to get 10 times 10a plus b. So this product must be divisible by 8. And how many factors does 10 have? It has 2 factors, 2 and 5. Therefore, the number 10a plus b, or in other words, the number ab, must have factors of 2 2's. And how do I know this? The reason why for this is because a number divisible by 8 is in the form of 8 times some number of n. Therefore, 8 has a factor of 2 times 2 times 2 times n. So whatever this number is that is divisible by 8, it must contain at least 3 2's in order to be divisible by 8. Hence, since 10 already contains one of the 2's necessary to be divisible by 8, the number 10a plus b must contain the remaining 2 2's to be divisible by 8. So now we have further restrictions on a and b. And with this restriction, what can we say about the number ab as a whole? AB must be divisible by 4 and must be even. Why is that? Because since a and b has a factor of 2 2's, it must product to 4. So it must be divisible by 4. And since it's divisible by 4 and it's even, b must be even. Because if it's not even, it's not divisible by 4. And it's not divisible by 2. So that won't work. So we must have a further restriction on b. B must be even. The number AB must be divisible by 4. So now we are ready to apply it with these two given conditions to find the possible solutions of this question. So first of all, let's write down our given conditions right here. First, let's apply to a plus b is equal to 6. This is our first scenario. And since b can only be even, b can only be equal to 0, 2, 4, 6, and 8. And when b is equal to 0, 0 is neither even or odd. But we must consider 0 because a 2-digit number that ends in 0 is considered even. That is why we must have 0 here. So with b is equal to 0, a is equal to 6, a is equal to 4, a is equal to 2, a is equal to 0, and a is equal to negative 2. And right off the bat, can this scenario work? The answer to that is no, because the 10th digit of a 2-digit number cannot be negative. So this is wrong. And what about this scenario when a is equal to 0 and b is equal to 6? While the sum of its digits is equal to 6, the number itself, which is 6, cannot be divisible by 4. So this scenario does not meet all the criterias. And what about the number 24? Well, the number 24 has its digits summed to 6, and 24 as a number is divisible by 4. Hence, this is a scenario that checks out. So let me box this in red to signify it's one of our solutions. And what about the number 42 when a is equal to 4 and b is equal to 2? Well, this will not work because while digits sum to 6, the number itself is not divisible by 4, which does not meet all the criteria, so this is wrong. And what about the number 60? Well, the number 60 has its digits summed to 6 and is indeed divisible by 4. Hence, this is a scenario that works. So let's box that up. And now we have the numbers from this scenario, which is in the form of 4AB8. So this number is 4248 or 4608. And now for our second condition, which is when a plus b is equal to 15. And likewise, b can only be equal to 0, 2, 4, 6, and 8. And when b is equal to 0, a is equal to 15, 13, 11, 9, and 7. And right off the bat, we know that these two solutions right here won't work, and this solution, because a, which is the 10th digit, has 2-digit numbers for it. So these three solutions right off the bat are not solutions. And what about the number 96? And 96 have its digits to sum to 15 and is in fact divisible by 4. Hence, this is a solution within our second criteria when a plus b is equal to 15. What about the number 78? 78 is not divisible by 4, but has its digits summed to 15. Nonetheless, it does not meet all the criteria, so this gets crossed out. So the number obtained from this solution is 4968. So while we did come short of our 4-digit, when I first in the beginning of the video said that there are 4 solutions, that's wrong because this is all 4-digit natural numbers. It never said there are 4. So do apologize on my part there. So we got 3 solutions of this form which meet the criteria of being divisible by 2, 3, 4, 6, 8, and 9. Therefore, we just need to find the sum of these numbers and we will be done. 4248 plus 4608 plus 4968. The sum of these two numbers is equal to 9,856. Added to 4968 will give us a total of 4, 2, 8, and I did a summation error here. That's supposed to be 8. So this should give me the right answer. 6 plus 8 is 4, 2, 8, and 13. So the answer is 13,824, the solution to this question. And you see here how elegant and straightforward the logic is once you truly understand this question. So when you first try this question out, don't be afraid to make mistakes and get things wrong because, trust me, I have gotten this wrong many times in the making of this video. So never be shy about testing different hypotheses and theories about what might work and what might not. That is the adventurous theme of competition problems. But nonetheless, the solution is 13,824.